In this question, he has given two identical three-phase alternators which are running in parallel and sharing load equally. Okay, he has given total load current IL is equal to 1093.5 amperes. Since load sharing equally, alternator 1 will share a load of 1093.5 by 2, which is equal to 546.75 amperes. Similarly, which is equal to load current of alternator 2. Now, since this current is sharing at a power factor of 0.8 lagging, so what is the active component here? Active component is equal to 1093.5 into 0.8, that is cos phi, which is equal to 874.8 amperes. Similarly, reactive component is equal to 1093.5 into 0.6, which is equal to 656.1 amperes. Okay, since load sharing equally, IL1 is equal to IL2 is equal to 546.75 amperes. Similarly, active component is equal to of alternator 1, which is equal to 874.8 amperes by 2, which is equal to 437.4 amperes. Okay, this is equal to active component of alternator 2. Similarly, reactive component of alternator 1 is equal to 656.1 by 2, which is equal to 328.05 amperes. This is nothing but a reactive component of alternator 2. Okay, and in question he has changed one machine excitation. Okay, since steam rate is same, he didn't talk anything about steam rate. Okay, since steam rate is same, active component remains same. Okay, excitation changes. If excitation changes, what happens? Reactive component is changed. Okay, since excitation changes, reactive component will be changed. Okay, now if you see the reactive component is 438 square minus 437.4 square, which is equal to 22.91 amperes, approximately equal to 23 amperes. Now what is this 438 square here? Okay, in question he has given that armature current of one machine becomes 438 amperes. Okay, that means he has given total current IA as 438 amperes. Since it consists of two components, that is active and reactive components. Okay, now what is the reactive component here? Total current square minus active component square under root, which gives you reactive component, that is 22.91 amperes. Okay, now what is the reactive component of machine B? Now reactive component, this is reactive component of machine A. Now what is reactive component of machine B? Reactive component of machine B is 656.1, that is total reactive component minus reactive component of alternator A. Okay, that is 23 amperes. Okay, now what is this one? This is equal to 633.1 amperes. Okay, now tan phi B is equal to reactive component, that is 633 point around 19 by 437.4, which is equal to 1447. Okay, now cos by B, that is equal to power factor of machine B is 568 lagging. Okay, option D. A power system networks consists of three elements. Okay, he has given three elements between three nodes 0, 1 and 2, impedances of 0.2, 0.4 and 0.4 respectively, and he is asking to find bus impedance matrix. Okay, now to find bus impedance matrix, first locate the impedances between nodes. Okay, this is J 0.4. What is this admittance here? Minus J 2.5. Similarly, admittance for this one is minus J 2.5, and similarly admittance for this is minus J5. Since these are impedances, admittance is equal to inverse of impedance, that is 1 by J 0.2, which is equal to J5, that is minus J5. Okay, now you can find Y bus matrix using direct admittance method. Okay, this is 1, 2 and 0. This is minus J 2.5, minus J 2.5 and minus J5. Okay, we can find Y bus using direct admittance method. Okay, this is what we are using is direct admittance method. In direct admittance method, the diagonal elements are represented in positive manner and half diagonals are represented in negative 1. Okay, if you see here in node 1, okay, you can locate this as 1, 2 and this one as 1, 2. Okay, now what is the corresponding admittance to node 1? Okay, node 1, it is connected to two branches. This is minus J5 and minus J 2.5. So this is having admittance of 7.5. Similarly, what is the admittance between 1 and 2 nodes? This is minus 2.5 and this is minus 2.5 between 2 and 1. Now what is the corresponding admittance value for node 2? Node 2 is connected between this 2.5 J and this is minus J 2.5. So this is plus 5.0. Diagonal elements are positive whereas off diagonal elements are negative. Okay, now he has to find Z bus. Z bus is equal to Y bus inverse. You will get Y bus inverse as 0.16, 0.08, 0.08 and 0.24. That is option B is correct. Match the following zero sequence networks, list 1 with list 2. Okay, you can see in list 1 different types of transformer connections, whether it is star or delta in primary and secondary. Okay, you can see in list 2 their corresponding zero sequence networks. You have 4 options, you have to select one. Okay, now how to find zero sequence network? When you are drawing zero sequence networks, okay, what is the reference one? Reference should be ground. Okay, reference is nothing but an ground. Okay, mark impedance like this and you have two switches in primary and secondary. Okay, and shunt switches you have in this way. Okay, series switches should close when you have star with grounded. Okay, shunt switches should close when you have delta connection. Remember this, then the zero sequence networks will be easy. Okay, now this is one switch, this is second switch. Let us take these shunt switches we have. Now let us see for zero sequence network for A. Okay, this is a transformer. In this transformer we have star grounded to star grounded. Okay, if you have star connection, series switches should be closed. Okay, star grounded, so series switches should be closed. Now what is the corresponding network we have? A is option 2. Okay, A is option 2. Now what about B? In B you have star grounded in primary, that means this switch should be closed, and isolated star in secondary. Okay, since you have isolated star in secondary, what about this secondary switch? This should be open. Okay, now what is the corresponding answer for option B? I mean list B. This is A. Okay, B is 1. Now look at the third one we have. Third connection is star grounded and delta. Okay, if you have star grounded, that is this primary switch is closed. Okay, and secondary switch is delta. Okay, delta is secondary, so this is closed. So option 3 is C. So which is correct option here? Option A you have is correct.